Algebra 2 skills number 20, the rational root theorem. So let's see what the rational root theorem does for us. We're going to let P represent the factors of the constant of some polynomial function. Q we're going to let be the factors of the leading coefficient of that same polynomial function. Our possible rational zeros of that polynomial function are going to be found by P over Q. So we'll talk about what possible rational zeros are as we go along here. So as a first example, what are the possible rational zeros of this given polynomial function? We put the constant in red and the leading coefficient in green, and ordinarily we're not going to be able to see that 1, but for demonstration purposes we made that a 1 here. So P, remember, are the factors of your constant. So what are the factors of 6? Well, they'd be 1, 2, 3, and 6. Those are the numbers that go into 6 with no remainder. Notice we put the plus or minus on there because you don't know what sign combinations you'll have for these factors. Q will be the list of all factors of the leading coefficient, which this time is 1. That's a short list. The only factors of 1 is 1. P over Q, or your possible rational zeros, are all these P's divided by all the Q's. So in this case, it's all the P's, 1, 2, 3, and 6, divided by your 1Q, which is 1, which generates the same list as our P's here. So it's nice when Q is 1. The P list actually is our possible rational zeros in this case. So let's talk about what that means. Possible implies that some of these might work, some of them might not. Rational means all values that can be expressed as the ratio of two integers, so no square roots or imaginary numbers of any sort. And zeros are values that when placed in place of x will make the function be 0. Okay, so let's try to actually find those rational zeros here. What are the zeros of this function? This is the same function that we had in example 1. We know our possible rational zeros are as follows. So what we need to do is begin with 1 and just try these until we get a 0 remainder. A 0 remainder indicates that we have found a 0 of the function. I recommend you always start with 1 because A is going to be in every list, and B is just an easy number to work with. So let's try 1. So 1 is just what we tried. It's the first number from the list. And I put these numbers as the coefficient of our polynomial function. Remember, 0 accounts for that missing x squared. And just quickly with synthetic division, you drop the 1, multiply by the outside number, write it here, add, multiply, write it here, add, multiply, write it here. In fact, we get a 0 here. That's not always going to happen. We got lucky this time. Had 1 not worked, you would have tried -1. If -1 also didn't work, you would have tried 2, and so forth. And just going through your list. Only use numbers that are in the list, but 1 and -1 will always be in your list. Okay, so this does two things for us. We found a rational 0. We expected 3 because that's going to match the degree. That's one thing it did for us, but it also simplified our polynomial function, and we can now only have to work with this quotient. So we expect our other two zeros to be in this quotient, 1, 1, and -6. Let's continue. So 1, 1, -6, that was the quotient. We're now going to continue through the list if necessary, but here we actually don't have to because since it's quadratic, that factors easily. I can just, once I get it down to quadratic, you can abandon the list and just factor. So that factors into x plus 3 times x minus 2. Our first, let's go back and look, our first 0 that worked is 1. A 0 of 1 is the same thing as a factor of x minus 1, because if you set x minus 1 equal to 0, you're going to get 1. So when you convert from a factor to a 0, when you put an x onto it, also change the sign of what you have. Okay, so we factor. The original factor is x minus 1 because it worked when we put 1, it gave us a 0 remainder. So all factors are this, but the so x plus 3 and x minus 2 came from this, and x minus 1 was the original. But the question asked for zeros, so we make that conversion. We set each of those three equal to 0. We get -3, 1, and 2. -3 and 2 we found by factoring right here, and 1 was the original one that worked. Notice that these three numbers were all in our original list. Okay, all of the numbers, all of our zeros were in this list. Now some things in this list didn't work, and that's okay, but all of our zeros were in this list. Okay, so let's look at a second example to try to make that a little clearer. So here we have another polynomial function. Now our p over q, notice again q is 1, so it's not going to be an issue. We can just be satisfied with the factors of 30. There's a lot of factors of 30. Let's try 1. Okay, without going through the process of synthetic division. We said we don't get a 0 here, so 1 is not a 0. All right, so what we should then do is go to -1 next. 1 didn't work, try -1. -1 happens to work. So like before, we can work with this simplified quotient. Okay, so we're going to do that. Okay, our quotient had coefficients as such in the previous slide. Okay, so now you could try -1 a second time, but it doesn't work. Okay, 1 will not work here. It didn't work the first time, so it's not going to work anytime during this problem. But if I go back in my list, I see that my list was, go way back here and look at my list. 1 didn't work, -1 did. But -1 doesn't work again here. So we're just going to go to our next number, which is going to be 2. So let's go back. There's -1 where it worked. We're now going to try 2, and it works again. So 1 worked, 1 did not work, -1 did, and 2 did. The reason I had to go twice here is because I didn't have a quadratic when I found the first one. I started with a quartic and worked my way down to a cubic, but I couldn't factor that cubic, so I had to go one more time. Now I've got it down to a quadratic. Okay, so 1, -8 and 15. All right, so you can read there, 1, -8 and 15. This is a trinomial that will factor. It doesn't always factor at the end, but often it does. So x minus 5 and x minus 3, that's just the numbers that multiply to 15 and add to -8. Remember, the first two that worked were -1 and +2 when I did the synthetic division. That's the same thing as x plus 1 as a factor and x minus 2 as a factor. Remember, whatever works with synthetic division, when you change that with an x, when you put an x on it, you have to change the sign. So -1 worked, gave us x plus 1. 2 working gives us x minus 2. And these two came from the last two we found there. So those are my zeros. Notice again that in that original list, which I won't go back and show you, but you might want to go back, those numbers were all in that original list. Okay, so one more example. Here we're only going to make a list again, but we'll not illustrate what happens when q is not 1. Usually it is, but what happens when it's not? So p, remember, without color coding this time, p, that's the factors of the constant, plus or minus 1, plus or minus 2. Q is the factors of the leading coefficient, plus or minus 1, plus or minus 3. And we divide every p by every q. Okay, so that's 1 over 1, which is just 1, 2 over 1, which is just 2, but then 1 over 3 and 2 over 3. So these are your possible rational zeros. We're not going to actually find them here, but if you were working with this list, I recommend you go through all of the non-fractions before you worry about the fractions.